This is an example of an indefinite integral. So we know it's an indefinite integral because there are no bounds on our integral symbol. And so what that tells us is we're going to get out an equation for our answer, an indefinite answer. So from here, we're being asked to take the antiderivative of x cubed plus 5x squared minus 7x plus 3 dx. The dx and the integral symbol up front, those are just directions. This is saying take the antiderivative of all of this stuff and that this is the letter that I care about. So really these are directions bookending what we're looking for, which is the antiderivative of the piece in the middle. We only have a bunch of stuff being added and subtracted here, and so we're going to apply the main antiderivative rule, which is your power rule. We had a power rule for derivatives, you're going to have a power rule for antiderivatives. The process for the power rule for antiderivatives just says add 1 to the power, and then step 2 of the process is divide by the new power. So working our way through this, you just break it up into smaller bite-sized problems by the pluses and the minuses. So starting at the very front here, we would add 1 to the power. That's going to get us x to the 4th, divide by the new power, which is 4. Plus, go to the next one, add 1 to the power. I get 5x to the 3rd, divide by that new power, divide by 3. Then we have an unwritten one for our power here, so add 1 to the power. We get minus 7x squared, and then divide by that new power. And at the end here, we've got a number by itself, a constant. Numbers by themselves when we were taking derivatives went away. When we're undoing derivatives, when we're doing antiderivatives, numbers by themselves gain an x. And so that's going to be 3x. At the end of all your indefinite integrals, you always want to put this plus c. This is what gives you a family of answers. We don't know if there was a constant at the back end of this or not. No matter what, if there was, the derivative of any constant would be 0. So we're not certain if it was there or not, but we track the fact that it could have been there by always putting a plus c at the end of all of our indefinite integrals. And so that would be our final answer for the antiderivative of this equation. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.